Hello everybody, thank you for coming. My name is Matthew Hasler. I'm going to talk about delivering incrementally and particularly breaking up features that span multiple services and multiple systems. That's who I am, Matthew Hasler. I'm a Senior Principal Engineer at a company called Trainline, which you very likely have not heard of, but I'll talk about Trainline in a moment. I was supposed to be doing this talk together with somebody else, with Conoce. He couldn't make it here, he couldn't get a visa to come here essentially, so I'm doing it. The idea is with this is because we're talking about breaking up features that span the front end and the back end. Conoce is a back-end engineer, and that's why it kind of made sense to sort of do this two-person talk, but yeah, like I say, you've just got me today. So Trainline is the world's leading independent rail and coach travel platform. There are some stats about who Trainline are. So we sell lots of train and coach tickets. It's quite an old company in tech terms, 25 years old, and it's very, very well known in the UK, but also, there's sells tickets across Europe as well. So the way I usually explain it to people who are not from the UK is, if you walk through any kind of busy train station in London and just sort of look at what people are looking at on their phones, most people are looking at the Trainline app. So it's really kind of a well-known app and sort of a well-used app in the UK. Okay, so we have offices in these places: Edinburgh, London, Paris, Milan, and most recently in Barcelona. So the Barcelona office is here. And we are hiring. And we're hiring all sorts of developers. So as I say, I'm from the apps team, so I have an iOS background working in Swift, but there's Android developers working in Kotlin, and backend developers working mostly in .NET, and web developers working in JavaScript and React. So yeah, there's plenty of development going on. So what am I going to talk about today? So as I said, I'm going to talk about problems with features and building big features that span multiple platforms. And this is based on personal experience on a project that Conoce and I worked together on. But I won't go into the details of that project. I'll talk about this example project, which is this sandwich picker feature, and I'll explain that feature. And then the two main bits here, I'm going to talk about breaking down how we break down the front-end implementation, so from the app side, how we break it down. And I'm talking about an approach called interface-driven development. And then I'm going to talk about sort of the same thing but zoomed out, so breaking down the implementation across the platforms, and I'm going to talk about consumer-driven contracts for that. And then at the end, I'm going to put it all together and show you how you can follow those approaches and build like a well-tested solution that covers multiple platforms. So that's what I'm going to start with. So you probably know this question: how do you eat an elephant? Does anyone know? One bite at a time is the answer. How do you build a large feature? So the answer to that is kind of the same, incrementally, basically, bit at a time. So we all kind of know this, and agile development is sort of the standard, I would say, in our industry. I think, we all work in this way. The problem, I think, is that, the Agile Manifesto and the Scrum Guide give you a kind of a framework to follow, and XP practices give you a framework to follow, but everybody kind of does it slightly differently. And I'm sure everybody's experienced this. You go to one place that say we do agile, then you go to another place and it's completely different. So what agile meant for the feature that I'm talking about, or the feature that I worked on together with Conoce, is that the individual teams worked in a very kind of agile way, but if you kind of zoom out and look at the process overall, this diagram looks like waterfall, essentially. So the back-end teams would build something, and then once they're ready, they would give it to the gateway team, and then they'd give it to the front ends, and then only once it gets to the front ends do we realize all of these kind of problems, and then we have to go back and all of the problems that come from waterfall. Yeah. So at the end of building that feature, so one thing I forgot to mention is, this timeline here. So this took a long time because of all of these problems. So this is more than 2 years to build this feature. So at the end of building this feature, we had a post-mortem session, kind of like a retro. Everybody in that session agreed that the number one problem was this early integration. That we We should have integrated the services more earlier. And these comments here these are real comments that were raised in that session. But although everybody agreed, nobody could really put their finger on actually what we should have done different. On a technical level, what could we have done differently? Because when you have these big features, it's sort of hard to imagine what a kind of incremental delivery looks like, because it's sort of all or nothing. So let me just summarize the issues of that feature. So we've got the long feedback loop. As I say, it's only once we got to the front-end channels that we realized there's all these problems with the back-end system. And the integration issues were discovered very late. It was very expensive to fix at that point, because those back-end teams, once we discover those issues, they've already moved on to other features, and they have to pause that work and then reallocate the people. We have designs and redesigns, and ultimately the release was delayed. So what did we do wrong? Well, you may have seen this before. This is Conway's law. Any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So in other words, you ship your org chart. So you've probably heard that before. And there's definitely some truth in that in our case. This was our company structure at the time that feature was built, and it's basically that diagram, right? The problem is that those teams are separated, although there's some communication going on between them, and they're sort of collaborating and discussing how they're going to build this thing. Essentially, they're kind of separate teams. But we've kind of changed the company structure since then, and now we have feature teams, and probably a lot of people here working in feature teams, where you have a team that includes back-end developers and front-end developers together, and this definitely helps. This is there's more communication, there's more collaboration, but it doesn't, even though you've got those people together in the same team and in the same stand-up, you kind of haven't solved the fundamental problem. The problem is that you can't solve everything with process, right? Sometimes you need a technical solution, and what I'm talking about here is the technical details of how to kind of, build this kind of big feature. So I'm going to talk about the example feature now. As I say, this is a sandwich picker. First of all, I need to explain, the Trainline app, because as I mentioned, it's not so well known in Spain, but this is what it looks like. You can choose your journey here, and then you get results. So I'm doing a search from Barcelona to Madrid for tomorrow morning, and then you choose your seat, and then you can buy your ticket in the app. So that's what the app does. That's kind of normal sort of buy flow in the app. So we're going to imagine a new feature that adds into that buy flow and goes in between the picking your journey and picking your seat. And at this one, we're going to pick our sandwich that we want for our journey. So, on the train, somebody's going to bring us a sandwich that we've chosen, so we can eat it on our journey. So let's imagine this. This is an example feature, right? But let's imagine that we've got some endpoint that's going to give us those sandwiches, and we've got another endpoint where we're going to select, which passengers want which sandwiches. This is all kind of, it's just an example. So with that in mind, we're going to try and break down the front-end implementation of that feature. So the front-end devs are going to come to this, and they're going to look at this design. First of all, probably a designer has provided this, and they're going to start sort of thinking, okay, what do we need here? What do we need on this screen? And then the next thing they're going to say is, well, what's the next level down in the architecture? They're going to start thinking about the presentation logic that's needed to feed the data for that screen and to handle the interactions, and then they're going to start to think lower down, and they're going to plan out this kind of, probably mostly in their head, they're going to start to plan out this whole feature, in terms of caches and database storage and business logic and the network part there. But obviously, this is not how you would build it. There's too much here, right? You can't. You've got to break this down a bit. You can't just go off and build this, because there's too much there. So that's the layers of the architecture labeled there. So then this is all normal stuff, right? We're going through the process of estimation and kind of breaking down that task into smaller tasks, and then what we end up with is like a thin slice And what I'm sort of representing here is this is a vertical slice that we're talking about. There's different ways that you could break up this diagram, right? You could kind of cut along those horizontal lines as well and break up the architecture, which is what we're going to do in a minute. But right now I'm just talking about the way we break that up as a team and following sort of agile methodology. We break that up into a very thin slice that we can deliver that goes all the way through the architecture. So perhaps this is kind of the first acceptance criteria that we'll sort of pick off. We're trying to pick the very smallest thing that we can build. So given that the sandwich API is going to respond with no sandwiches at all, when the sandwich picker screen launches, then we want to see no sandwiches available. So this is like, as simple a kind of feature as we can get, and so that's what we're going to focus on. So that's a design we've got. There's no sandwiches, and my Spanish is terrible, omitir, that skip button. We're not even going to do that button. So we're just going to show this message. We're just going to show no sandwiches available, and we're not even going to worry about the button or the interaction. We're doing the very thin slice that we can possibly do. So a big part of this is that we need to wrap this work in a feature toggle. So this is very important for this way of working because this feature is useless at the moment, right? You can't ship this to the customer and say there's no sandwiches available, right? So we have to have feature toggle. So this is really important for kind of how we build these features. Okay, so we've broken this down, this feature down, and we've got a ticket in Jira. We use Jira, but you may use another system, but this is what it would look like in Jira. We've got a ticket created for that very thin slice. Yeah, we can go back. So now we're going to pick up the ticket, and the problem is we've got this team of people. Let's say we've got 4 or 5 developers ready to work on this, but the problem is there's too many developers basically. Like, what's the next feature after this? Like, maybe the next feature would be the skip button, implement that skip button. But the problem is that this task is in serial, right? You kind of have to build that screen before you can build the skip button. So we have to focus on this task before we move on to the next one. So this is why I'm going to talk about mob programming. So you may or may not know about mob programming, but this is a software development approach where the whole team is working on the same thing at the same time, in the same space, and at the same computer. And so space obviously can be, virtual space where most people are working remote these days. So this can be a Zoom call. But the point is that everybody is sort of focused on the same problem together. So it's like pair programming, but there's just more people basically. So one person is driving, and then typically you have a navigator. You can put lots of different rules on it. I'm not going to go into too much detail. There's a really good book that I very much recommend reading if you're going to sort of look into mob programming. That kind of goes through the practical details of doing it. But I'm not talking about mob programming for building this whole feature. I'm talking about it in a very specific way. So we are going to use it to do the kind of planning phase of this feature. So it's not the same as the grooming that I've already talked about, where we sliced it vertically. So this time we are going to slice it horizontally, and we're going to do this as a mob, as the developers, not the whole team, not the not the product owner and all of that. Just the developers are going to mob on this, and they're going to separate the feature along the lines of the architecture, so horizontally. And they're going to define the types and the interfaces, in the feature. And the reason I'm calling this mobbing and not planning is because the output of this is actual code, as I'll show in a moment. So this is kind of the thin slice that we've come up with. We've got the user interface at the top, we've got the presenter, we've got this manager object, and then we've got this API, and then we've got the network out there. So now we've got those, we've decided in our mob, we've decided those are the layers that we need to build. We're going to go back to Jira, and we're going to convert those into subtasks, and pretty easy. The first bit is just a one-to-one mapping. There's a sandwich view, there's a subtask to build a sandwich view. And when we're creating those subtasks, it's not just the title, there's detail in there about edge cases or stuff that we thought of, or stuff that's come up in that discussion and that mob, and stuff that we're going to have to tackle when we get to building that actual layer. So another thing on that diagram, which we haven't captured yet, is the arrows between the boxes, and so that's what that first subtask is. So that's implement the interfaces. So the way that those different layers talk to each other. And the missing subtask is to write a UI test. So the wording here is a bit confusing. We call it a UI test. It's really an acceptance test. It doesn't just cover the UI. It covers the whole system from the view down to the API level. Cool. So we've got these subtasks, and now we're going to actually pick off the first subtask. We're still in our mob at this point. We haven't like disbanded. We're still all working together. And this is where I say we're actually going to produce real code. So this is the iOS app, so this is Swift code. So protocol here is the same as interface for people from Java or C# or whatever. So we've defined these protocols to define how the different layers talk to each other and the functions that they need to call. The only thing we need on the view is to be able to display no sandwiches, so that's the only function that we have. And then when we actually fetch the sandwiches from the network, we get an array of sandwiches. And because we've defined this sandwich object and this error object, we need to define those, because we've referenced them, we need to define them here. But importantly, because we've picked such a thin slice, we don't need anything in this sandwich object. We don't need the name of the sandwich or the ID or anything, because we know that we're not going to get any. So there's no point in defining it just yet. We've just defined enough just to make this work. So, yeah, like I say, we've written real code as a mob. It doesn't do anything at all. It's just the interfaces. Maybe you need a review at this point, maybe not. I mean, that's going to depend on exactly what it is, but sometimes we just would merge this because everybody on the team has seen it. And sometimes if it was a bit more kind of controversial or a bit bigger, maybe we'd get a review from someone outside of the team. But the point is that PR gets merged into the main branch, and this is like real, we're not working on an epic branch, or this isn't just like a kind of plan, like this is actually going into production code. So we've completed the first subtask, and yeah, so here we are. So the big benefit of the working in this way is that although now up until now we've been mobbing, we've all been working together, now we get a big sort of benefit of parallelization, because all of these tasks, the UI test and each of these layers, implementing each of these layers, all of this stuff can be done in parallel at this point. We've defined all the interfaces, and each of those layers can be built just against, mocking out the next layer. The slight exception to that is the UI test. We can write the UI test straight away because we know exactly what it's supposed to do and what's supposed to pass, but we can't merge it until all of this, it's not going to go green until all of these layers are built, because it's testing the whole, as I said, that's the acceptance test, it's testing the whole system. So that's a big benefit of parallelization. We have fewer conflicts because people are working, they're just focused on the layer that they are building, and even if all of those PRs were opened at the same time, there's not going to be any conflicts because everybody's just on their particular layer. There's no kind of overlap at all. And an important point is that you can prioritize the subtask to unblock other streams of work. So an example that we get quite often is that the UI layer needs translations. So we need to that needs to go off to a translation service, and then that takes a couple of days for all the translations to come back in all the different languages. So if that's the case, then you might prioritize the UI task to make sure that those that those translations are kind of in flight, and then you can work on the lower level logic and save time. And as I mentioned before, even if all of the tasks that you're kind of planning for this feature, even if they all have to be delivered in serial, you can still work, because you're breaking this thing down horizontally, you can still work in parallel, and you can still have all the developers working together on the feature. So very importantly, this allows like a very test-driven approach, because you're kind of stubbing out each of the other layers. When you're building one of those layers, like the presentation layer, you're completely using TDD, like 100%. You're completely driving everything you do with tests. We follow the overall acceptance criteria that we got from the parent ticket, so that in that original breakdown that we did with the team, But also, we raised some edge cases during the mobbing, so we've got some other stuff there that's going to feed the kind of tests that we write as we build out each of the layers. And so, like I say, the team ends up spending most of their time working in TDD, and hopefully that leads to fewer bugs, and it leads to less wasted code, because we only build the thing that we actually need. We don't sort of over-architect, I guess. So another benefit of this is that we have the progress that we're making on the task is very visible. We've broken down this ticket into subtasks, and we can see very easily, you know, what's in progress, what's still to do, what's done. And when you have your stand-up, you don't just say, you know, I'm still working on this ticket. You can actually kind of communicate very clearly. This bit's done. This bit isn't done. This is the thing that's blocking me. It makes that kind of whole process much easier. And if you've forgotten something, which happens quite often, like you did this kind of mobbing session, but then you realise as you build it, oh, there's something we've forgotten. We need an extra boolean in the interface or something. Then at that point, what we do is we create another subtask to capture that change in the interface, and then once that subtask gets, you know, once that ticket gets merged, then we've unblocked the two layers either side of it, and again things can continue in parallel. So anything like that, it's not like just this is some sort of, you know, spanner in the works and it just sort of threw the timelines off. You actually document exactly what went wrong and what we missed and what we did to fix it. And also it makes it very easy to judge the amount of carryover. So if you don't finish this in the sprint, then you can see exactly which subtasks are done and which aren't, and which ones you're carrying forward. It helps a lot with knowledge sharing. So there's lots of documentation that you're sort of producing through this process in Jira, in particular. The whole approach to the feature from an architectural point of view is kind of documented in those tickets. And the whole team is involved in doing that subtasking. As I say, it's very inclusive. So even the more junior team members have sort of designed this system. And the fact that you've standardized the Jira layout, because, you know, as you sort of work in this way more and more, it becomes really easy to sort of read Jira and understand like the progress of all of the features that are happening, even for the people outside of the team. Code review becomes much easier. Typically, once you've done that first PR, that interface PR, you know, that PR kind of sets up the whole structure for you to do the next subtasks. So, but those next subtasks are they're just focused on one layer of the architecture, and usually they only contain two files. They've just got the file with the implementation and the file with the test, so they're really easy to review. And added to that, the other developers have already got the context of what they're reviewing, because they were in that mobbing session. They already understand what this is supposed to do. So it makes this whole review process really smooth. And the comments in the review can focus on the implementation and the approach taken to the implementation, because we already understand the design, and, you know, everything else is sort of moved out of the way. Yeah, great. So this is interface-driven development, and these are the summary of the benefits that we're getting from there. So the parallelization, the fact that this kind of allows a very test-driven approach, the visibility of progress that we have, the knowledge sharing that's going on, and the fact that it makes code review a lot easier. Cool. So I'm going to go back to this diagram now. So up until this point, we've built out the front end, but we've still got the same problem that I described at the start. We're still, we've depicted the back end as just a cloud. Right? We're not sort of thinking about the other team at all. We're kind of, we're not involved in building this feature. So how do we do better? So now I'm going to talk about kind of the same concept, but this is now sort of zooming out and looking at the communication that happens between the app and the back end. And we're going to talk about consumer-driven contracts. So first of all, what do I mean by contract? So a contract, just like those kind of arrows in the diagram before, a contract is a documented, shared understanding of the messages an application sends or receives. So for HTTP, this is the requests and the expected response. If you've got a queuing system, then this is the messages that you expect in the queue. We're not talking about that today, just the way that the systems communicate. So typically, if you're not doing consumer-driven contracts, you're doing provider-driven contracts. So this is kind of how we would work in the past. This is kind of that waterfall. The provider, the back end, or the gateway service is telling us this is what you need to do. This is the API that we're giving you. This is how you get your sandwiches. And then it's down to the consumer, the iOS app or whatever, to look at that and think, okay, what do we actually need here? What do we, how can we use this and map this into the models that we need to display in our UI? So consumer-driven contracts sort of flips the relationship, in this case, the consumer is going to define exactly what they expect to receive in certain situations and deliver that to the provider in the form of a contract. So let's go back to the simple example again. We're talking about just the case when there's no sandwiches at all. So when we call the get sandwich endpoint, we're going to get an empty array of sandwiches. But there's one bit missing in this contract, which is the provider state, because we only expect to get no sandwiches if there are actually no sandwiches available. That's kind of important for the test. So what we've kind of produced here is a given when then. So given that there's no sandwiches available in the back end, when we make the request for sandwiches, then we expect to get no sandwiches. And that fits with this quote as well, because he says consumer-driven contracts are like TDD applied at the API level. So that's exactly what we're talking about. So I'm going to go through the process, sort of the overview of the process of how consumer-driven contracts works, and then I'm going to show it in detail with actual code as well. So there's 3 steps. Step 1, the consumer writes a unit test, so using those expectations that I mentioned, and then the SDK that we're using to write these tests is going to record those expectations, record that contract, and then that's what we pass on to the provider. The provider then can write its own unit test based on the contract that they've been given. So those are the 3 steps. Let's do it in practice. So we're going to set up the expectations. So we need the provider state, the request, and then the expected response. And then to do this test, we're going to run a mock service locally. And then once that mock service is running, we can call our real production code. And then we're going to assert that the response is handled in the correct way. So what handled here depends on what handled means depends on the scope of the test. So in the example I'm going to show, we're just talking about the kind of the lowest level, the sort of API parsing layer. But there's no reason why you couldn't kind of extend this to be a full sort of UI test and include the whole stack and build a test against the whole, against the contract, testing all of the layers. So here we go. So now we've got some more Swift code. So the consumer has set up his mock service here. So given that there's no sandwiches available, when we send this request, we expect to get this response. And now we can run that mock service, and it's just going to provide that response given that request. And now we can call our real API, and then we get sandwiches, and then this is the actual assertion here. We can test that we serialize the sandwiches, and then we assert that the sandwich array is empty. And then we're done. That's our unit test on the consumer side. So step 2 is that we record that contract. So just running that test using that kind of testing SDK produces a definition of the contract, and it gives you a JSON file that describes that contract. And then you just export it and share it with the provider. There's a kind of system for managing this called a broker. I'm not going to talk about that today, but the point is that the consumer gives it to the provider in some way. So this is what it looks like. Pretty similar to what we just saw in this test setup there. You just end up with a JSON that describes the relationship between the consumer provider in terms of what it expects. And yeah, this is the important thing, is this provider state. There are no sandwiches available. That's really important, because that's the sort of setup of the test. So now this comes to the provider, and the provider can write a unit test based on that contract. So they, as I keep mentioning the provider states, this is the important bit, is that they need to set up those provider states. So in this case, it's quite simple because we're just saying that there's no, the provider state is that there's no sandwiches. So we're kind of assuming that our test is going to do some sort of database cleanup at the start anyway. So probably this provider state is just a no-op. We don't need to do anything. We don't need to add any extra sandwiches into the database. So now the backend can run the unit test using that contract, and they can test that if there are no sandwiches in the database and they get that request in, this is the response that's generated. Cool. So we've tested this contract on both sides, and the thing that makes this approach really powerful is that actually in reality we don't just have one client, or we don't just have one consumer. There's multiple consumers that are using this provider. So in our case, we're talking about the iOS app at the moment, but the Android app's probably got similar sort of requirements. But there's a web interface that's going to have different requirements. They need sort of different bits of data at different times to drive different parts of the UI. There's other apps as well that we drive, white label apps, and the contact center is also using the API. So they all need sort of different things from that contract. So each of those different consumers can define the bit of the the bit of the response that they are depending on, and then the provider can run their tests against all of those expectations and make sure that as they make changes, all of their consumers should be happy because we're meeting all of their expectations. Cool. So we've talked about the breaking down the front end and breaking down the kind of the implementation across the platforms. Now we're going to put it all together at the end and show how we can build a well-tested solution from end to end. So let me just remind you the bad way, what we used to do. So this is a complete exaggeration. In reality, it wouldn't be this sort of regimented, but this is essentially what we're doing. We're sort of building the lowest level thing, and then the thing that depends on it is getting built, and then this is what led us to the problems of all the problems I described at the start, and ultimately the fact that we delivered very late. So this is waterfall. So we don't want to do that. So the first thing we're going to do is, rather than build the whole layers, this is I guess the important thing here is about the two sort of directions that we're breaking this thing down in. So rather than building the whole layer, first thing we're going to do is just take a thin slice. So let's just imagine the thin slice we've already talked about. We're still going to just try and return no sandwiches, but we're going to try and do it all the way through the system now. So the first thing we're going to do is write the contract test. So from the point of view of the consumer, so I've coloured this test in red for now because it's failing. And then the next thing to do is to implement that API layer. And we've turned our test green. So now that we've got that contract in place, a whole bunch of other things can now happen in parallel. I'm going to not show them happening in parallel. I'm going to show them appearing one by one. But the point is that we've kind of allowed parallelization to happen all the way through the system now. So if the backend team is ready, they could write a contract test using the contract supplied by the consumer. And again, it starts off red. And now we implement the endpoint and we get the test to go green. So at this point, we've just built the first layer of the backend architecture, enough to make the response come back, given that all of the layers below is stubbed. But we could have done a contract test with a wider scope. So, like I said, the decision about what that sort of the scope of that contract test and how much it covers is going to depend on the feature. But so we could have a contract test that covers those first two layers. So either way, we're probably, when we build out this next layer, the business logic, we're going to also have a unit test, or have some unit test covering that layer. And they're going to be red at this point because we've just written them. Then we're going to build that layer, and all of this is going to turn green. So obviously I'm oversimplifying the TDD at this point. There's not just one test that's going from red to green. Like in reality, this is going through multiple cycles of red, green, refactor every time we're doing this. But the point is we're sort of able to build these layers in isolation. So now the app team have finished the mobbing that I talked about earlier, and they've written the failing UI test. So they've got a UI test that covers all of the layers that we talked about before. The slight difference now is that because we're using contract testing, we're still building this thing against the stub, but now the stub is a kind of formally defined stub, and it's been shared with the backend as well. So there's a bit more value in this end-to-end test now. It's not just a sort of something that's sort of hard-coded in the app testing code. This is something that's shared, with the rest of the organisation. So now they've got that, they've done the mobbing, they've got that UI test in place, they can build the rest of the layers of the architecture in whatever order works for the team. So we're going to start with the presentation layer here. We've got our unit test, and we're going to build the presentation layer, and we're going to make that test pass. And importantly, we haven't even built this layer yet, but we're programming to stubs, we're programming to interfaces, so this isn't a problem to do. So now we're going to do the UI. In this case, we're not going to do TDD because it kind of doesn't really work for UI, but we are going to write a test afterwards. We're going to write some screenshot tests to make sure that we don't break the UI in the future. So now the backend team are coming to the database, and let's say they write an integration test. Remember, all of this stuff is happening together. Like, I'm showing this stuff happening, in sequence, but in reality, all of this stuff is happening at the same time in parallel. So depending on the feature, you may want a contract and kind of even more extended contract test to cover the entire service. It's probably overkill for this particular feature. We're talking about just returning no sandwiches, but depending on what the feature is, you might, that kind of test might make sense. So we've got one more layer to go. Again, we're going to use TDD, and then we're going to make our test pass. And at this point, our acceptance test has gone green as well. So there you go. So we've got like I said, we've got an end-to-end solution. We've built it up bit by bit, and we've got very good tests covering every part of it. Some people kind of say that if you're using contract testing, you don't need anything more. You don't need kind of end-to-end tests or integration tests. I'm not completely sure if I agree with that. I feel like there's a place for those kinds of tests. The danger is, that you become too reliant on that kind of test, and you have a too large a suite of them, and these become big and flaky and hard to manage. But I don't think there's any, we could definitely come up with sort of integration tests that just cover the business logic of the front end app, but hit real endpoints, real sort of staging endpoints, and test the whole integration there. We could write a bigger integration test actually covering the presentation layer, or we could write a full end-to-end test covering all the UI and everything. As I say, it completely depends on the actual feature, but there you go. That's a full diagram of the different ways that we can cover features in tests. In reality, you kind of can pick and choose. You probably wouldn't write all of these tests, but even so, it probably seems like we've done an enormous amount of work, really, and all we've built is a thing that can give you no sandwiches. What did we achieve by doing all of this? So now we're getting very quick feedback. We're not having to wait till this whole thing has been built, from the back end to the front end. We get very, very quick feedback that all of this integration works. We're failing fast, and all of this development, as we saw in that diagram, all of the development is happening in parallel now. And each of the layers in the system are independently tested, and they can be independently deployed as well in the case of the back-end stuff. There's going to be fewer knowledge silos as well. People are having to collaborate a lot more. Like, as I said, sort of changing the process and putting people together on teams improves collaboration, improves communication, but with kind of changing technically the process, people are sort of forced to communicate. There's nowhere to hide, really. You've got to communicate, and you've got to share the knowledge, between the layers. The instant gratification, especially for the back-end teams, they're kind of it's not like they're building their feature and then at some point in 6 months or 12 months they're going to see it on an app. They're going to, the thing that they built today, they can probably see in the app tomorrow. This is much faster feedback for all of the teams. There's far less context switching. As well, like I said, we're not constantly having to go back and disrupt people's process because everybody's working together. which ultimately, hopefully, leads to a reduced time to market for the future. There we go. Thank you very much. I guess we've got a few minutes if you've got questions, yeah.
Yeah. Where would it be the design part?
The design part. Do you mean UI design or which design? UI design. So I guess UI design has happened in this feature that I'm talking about here. UI design has happened up front. That's a good point, that I guess UI is not sort of involved in this cycle in the way that I've described it, because I'm describing a technical cycle. Yeah, in the way that I'm describing it there, UI design happens up front, and then if there are problems, then there is a kind of feedback to the design, and there's iterations that happen now with the design team. But I suppose hopefully those iterations are happening much more often. We're not having to redesign the whole system because we've realised that something doesn't work in UI terms, right? Because for example, if there's something wrong with that no sandwiches screen, we're going to be able to fix that straight away. We're not going to wait until the back-end team have built their whole system. Does that make sense? Is that not? Does that answer the question?
No, I was wondering how are you doing it in your system.
Okay. So yeah, I guess the design is happening up front, and I didn't really cover design in this because I'm talking about the technical layers, but it's true that if something doesn't work in terms of the design, then the same kind of feedback loop is happening with the designers. It's the same. I guess in that mobbing session that I described, we can raise problems. We can go back to the designer. We can say, okay, this doesn't quite work. We need some more assets or whatever it is. Although the design is happening up front, then I guess this process, it naturally sort of leads to the design being involved all the way through, because you constantly have the opportunity to feedback to the design team. Does that make sense? Yeah? Okay. Does anyone else have any?
I don't know. First, thanks for the talk. I think it was very good. It aligns a lot with my way of thinking how to build features and this kind of stuff. I worked in video games before. There's a lot of front-end and back-end in there.
Yeah, right.
And we ended up with a similar approach, but instead of using contract testing, which I have no experience with and I think it's great. For API stuff, we use stuff like protocol buffers and gRPC and things like that. But it is a different way to define the contracts. But
yeah, I mean, contract testing works with protocol buffers as well.
Sure.
It's just a communication.
Right, it's just the transport, right?
Yeah.
So my question would be I think this is a pretty advanced way of doing things really good. And how hard was it to engage them, and especially for more junior people, they are not really maybe to testing or to do the things in a certain way, because you need to, this process looks really good, but also very specific, right? So how do you do that work of training the tests?
Yeah, so I can talk a lot about the subtasking part, and the contract testing is kind of the same but just zoomed out, right? But if I focus on the subtasking bit, the way that worked initially, I'm saying subtasking, interface-driven development. So when we sort of came up with this idea, we came up with this in the team, and we called it subtasking because we're creating all of these subtasks in Jira. We didn't have a better name for it. But since then, I've heard other people talk about essentially this exact same approach, and I've heard it called interface-driven development, which I think is a slightly better name. I still don't really like the name that much, but anyway, we came up with this idea, and yeah, it was kind of just an experiment at first. We just sort of, I guess I was sort of heavily involved in the architecture of the app, and knew that if we were sort of following this architecture strictly, then this is one of the benefits that we get from it, is that we'd be able to build it in this way, and we'll be able to separate it, and we'll be able to have very good testing along the way. But actually, the sort of getting people involved in it and upskilling it was pretty easy in a way. Like what we did was the first time we did one of those mobbing sessions, I think it was like the whole day pretty much. Like it took the whole day to do it, you know. And there were, I think, only maybe three or four people on the team on a Zoom call. It was actually a team in Paris, and I was in the UK, we kind of spent the whole day like discussing this thing and sort of breaking it down. And the first time we did it, it felt kind of wasteful. Like it felt like, well, we've spent a whole day and all we've written are these interfaces, really. Mm-hmm. But as we did it more and more, we sort of solidified it into these rules and this kind of thing. Like it wasn't, I guess you're saying, oh, it's quite a lot of process and it's quite strict, but that sort of came gradually.
Yeah, sure. Like or new hires and stuff like that. And the learning process like different because for me it looks great. Yeah, and makes sense, right? So
I think the problem is the thing that's difficult is to get people on other teams to follow it. The new hires isn't the problem. New hires going into that team or other teams where we sort of introduce this process, because it's not all teams will work in this way, right? Okay. But the teams where we've introduced this process, the new hires coming on sort of just fit in, and then they sort of, after a week or two doing this, they get it, and it's like, and they see the same sort of benefits that you see, right? They think that this is a really good way of working, and but the difficulty is getting other teams to sort of follow it, because you've kind of got to go through all of this and explain the whole point of it, because otherwise you have this feeling of like, why are we wasting all this time just talking, you know? why can't we go and write some code, you know? Does that answer the question?
Yeah, sure. Thanks. In this scenario, how the communication with the engineers of product will work? This part of the company or inside the tech will be in the mob programming, or?
No. So the mob programming is a purely kind of technical breakdown. So the bit that I said at the start, where we do kind of grooming and estimation, and there we're splitting the feature, we're making that thin slice. So we're splitting the feature that way in the diagram. That's the thing that happens with product, and that's, with Three Amigos and all those, that whole process of breaking down the feature and estimating and
from there it happens the design and then the engineering part, or?
It can vary. The design could have happened up front sometimes, but there might be some kind of prototype or something, that's why I thought this was a really good question about the design. Like, it kind of can happen in different orders. Does that answer the question? Yeah.
You don't want to make this question, but if you buy the interface, you define the interface regarding the consumer. You're not attaching the backend to a specific consumer, and you have to take out this consumer. You will have like a you have to create this code and backend is growing and growing depending on the consumers.
Yeah, that's right. Yeah. So I didn't go into a lot of detail about the contract testing, but there's one aspect of it is the versioning. So the consumers can sort of have their expectations against, next version, N+1 of the contract. So that sort of, I think, helps with the problem that you're describing of like the back end having to sort of meet all of these demands in one go, right? They can sort of use versioning to kind of incrementally meet those contracts, if that makes sense.